Welcome to FHIR Shorthand. I'm your host, Melinda Stewart from HL7. Our speakers today are Mark Kramer and Chris Moesel from FHIR. Our moderator on Whova is Brian Caney, and I'll now turn it over to Mark.
Hi, everybody. So Chris and I are going to talk about FHIR Shorthand. For those of you who don't know us, we're both from FHIR. We've been involved with HL7 for quite a long time, and we've been working on a variety of different projects. You'll see some of them over on the right. You may have heard of some of those. Inferno and Cynthia and CQL. We've participated with others on those, of course, but they're also FHIR products. And lately, we've been working on a COVID-19 with a large healthcare coalition of 500 companies. One of the products that's come out of that is Sarah Alert. We're a nonprofit company that works for the federal government for the most part. And when I say product, I'm usually referring to a free open source product like FHIR Shorthand. So what is FHIR Shorthand? It's a language that's been designed for profiling and for creating implementation guides. And there's a new project. We only started in October of 2019 putting pen to paper. We got out an early version in January. Now we've been on the ballot, May. We're currently used by approximately 40 projects that we know about worldwide. Shorthand is the specification, and I'll also talk about Sushi, which is a reference implementation of a language compiler. It's likely that the ballot, which we just had, will result in a couple of changes. I'll make an allusion to those as we go forward. So, next slide. So, what are the, sorry about that. So, what is FHIR and why should you be interested in using it? So, as I mentioned, it's a method of creating FHIR artifacts that you need for profiling. And what makes it different is that it has a declarative grammar. You specify what you want to do rather than how to do it. And that makes it quite readable and understandable. I won't say you stay completely out of the weeds, but you are specifying not the FHIR implementation as much as what you'd like to do. It also supports distributed development, and that's very useful for large IG projects where you have more than one person. And it supports source code control, giving you a detailed change history and version to version differentials. So if more than one person is working on it, you make multiple commits, you can always see what's happened historically. It's also very agile. FHIR Shorthand, which I should have mentioned, is FHSH or fish. That's why we have all these fish graphics and jokes. For jokes, fish is text. You can search, cut, copy, and paste the text, which makes it very easy to make changes, rapid changes to your IG. Why is it important to be agile? For those of you that have worked on IG projects, you can sometimes feel like that bloke in the middle there, being ganged up upon by a variety of different people and forces, you know, ranging from feedback that you get from your stakeholders, different design options, changes in FHIR that are happening simultaneously, getting feedback from connectathons and from the ballot, from other HL7 work groups that have interconnected projects. You are going to have to make a lot of changes as time goes by. And so it really pays off to have a methodology that allows you to make those changes rapidly. So how does FHIR as a method of creating FHIR profiles, extensions, and other artifacts like that compare to other profiling methods? Well, I know of 5 different methods of profiling, including FHIR Shorthand. And I classified them as point and click methods, declarative methods, and just plain ugly. The point and click methods, a lot of people use Forge or Trifolia. These are UIs that kind of guide you through the process of creating an IG, implementation guide. They're quite manageable. They help you along the pathway, so they keep you sort of between guardrails. The only disadvantage is that they are a little bit less agile. And if you have large scale changes to make, you're going to end up clicking a lot. So it's not quite as fast for large scale projects as FHIR Shorthand, which, as I mentioned, is a declarative way of specifying your IG. However, shorthand is not guided, so you need to know something about or what you're trying to achieve when you use FHIR Shorthand. It's extremely manageable and agile. And on the far right, just plain ugly. Some of you may be familiar with some of these techniques. The spreadsheet method is what we were using, 4 or 5 years ago. And some people still prefer to hand edit structure definitions, and there's nothing wrong with that. You just have to know what you're doing, since that can get very complex. Is fish right for you, or is your project right for fish? As I mentioned, it's self-guided. It's not a point and click interface. You should be familiar with FHIR profiling in order to use it. It doesn't hide all the complexities of FHIR, but neither does a point and click interface. The learning curve for FHIR Shorthand, I think you can learn a lot in 1 day, and you can master it in a week. That doesn't mean there won't be some questions that come up after that 1 week period. But there's ample support on the FHIR chat, the Zulip chat for you, and now a growing community of users. The other thing I'd say is that you need to have some sort of a programming mindset. That is, you're dealing with a formal language. It's like a computer language. You deal with compiling and debugging. You operate from the command window. You're also dealing with files and probably putting those files under source code control. So that means, you're not a complete neophyte when it comes to operating the computer in a mode that is like other kinds of programming. FHIR Shorthand is suitable for almost any IG or profiling project, big or small. It's very quick to get going on a new IG, and Chris will show you that later. Our Let's Build session will have you build a complete IG. So what does FHIR look like? Well, first thing I want to do is point you to the documentation. This is really essential, and you can find the FHIR Shorthand documentation on build.phir.org. If you're not going to copy down that URL, you can Google it, search it. Our current version that we're using for the Let's Build session is one version beyond the ballot version. It's 13.2. The other thing I would point to is that the documentation includes several different pieces. There's a very useful overview that I'll be quoting from during this session, and also the language reference is more or less something to look at when you have specific questions. There's Sushi, the implementation reference, which explains how to use the compiler. And then in the download sections, you'll find some very useful quick reference guides to print out or have in another window. And the reference guide has 2 sides when we print it out. It has some language patterns, which is the syntax, and some examples on the other side. So those are some things you'll want to keep close to your work when you start using FHIR Shorthand. So let me explain some basics about FHIR Shorthand. So in FHIR Shorthand, there's 8 or 9 different objects that you can define. These are items. Profiles, extensions, instances, value sets, code systems, mappings, rule sets, and invariants. Most of these things you'll recognize from FHIR, except for rule sets, which is a special construct in FISH. The file extension that you'll be using is .fsh. We call them fish files. And you can have multiple fish files per project. And just in keeping with this theme of aquatic theme, we call that a fish tank. A fish tank is nothing more than a set of files in a directory that are associated with one project. And the items, the profiles, extensions, and so forth, these can appear in any fish file within that fish tank without affecting the interpretation. So you can divide up your items any way you'd like, any way that makes sense for your project within that fish tank. So you may put all the profiles in one file, all the value sets in another file, or you can arrange it differently so that everything that's related, the profile extensions and value sets, they're all together in one file. Lots of different ways to do it. The primitive types and the values in FISH are identical to FHIR. You can have comments in FISH. We use the Java style. The double slash for a single line comment, or the slash star for multiple line comments. FISH is not white space sensitive. We use the asterisk to denote rules. We also have a special way for denoting codings, which is the code system followed by a hash sign, and then the code, followed by the display text in quotes. And something that's very useful, alias statements. You can alias any URL or a URI actually, and OID can be an alias as well, and I'll show you how to use that. So I'm gonna go over some of this stuff quite quickly because of time limitations, but you'll have a chance in the Let's Build to try them all out. So I'll jump right into how to define a profile. Basically, there's 3 different parts. There's a one-line declaration of the item type and the item name, followed by a short set of keywords, and then a set of rules. So I'm going to take these one at a time, starting with the item type and keywords. I guess I'm taking them 2 at a time. So in the keywords and items, so the item type is either, and I'll point over here to this table, it's either going to be profile, extension, instance, value set, code system, rule set, or invariant. In this example, it's a profile, and you follow it with a colon and then the name of the item. So we're defining a profile called cancer disease status, followed by a set of keywords. Parent is the resource or other profile that we're deriving this profile from. The ID is an identifier, unique identifier within the scope of this fish tank. The title is the way it's going to appear in the IG, and the description is a definition. It can be longer or shorter than what's shown here. And this table is just for your reference. It shows for each item that you can define which of these keywords are legal and which ones are required and which ones are optional. So next, and then the main part of FISH, are the rules. And the rules, as I mentioned quickly, start off with asterisk, and then they have certain syntax, the declarative syntax that allows you to say what you want rather than how you want it to be implemented. And we take care of the rest. So I'm going to walk you through some of the rules here. I won't have time to go through all the different types of rules, but I'm going to hit the core of what makes, let's say, the 80% of fish. Flags and cardinality rules. So flag rules are things like must support. So you'll label a few of your elements as must support. Often you'll label them with include in summary, or this is a normative, intended to be a normative element, or a trial use element, or draft element. And all you do there is you make a list of the names of the elements followed by the symbol. We use MS rather than S for must support, just to distinguish it from summary. We're doing plain text, and sigmas don't work very well if you're familiar with the way that those are depicted in a IG. Also, you can declare a extension as a modifier, but that's kind of advanced. Then cardinality rules uses the FHIR syntax for, or the IG syntax for upper and lower bounds, which is this 0 dot, or the lower bound dot dot upper bound. So what we're saying here in this example is that body site, specimen, device, reference, range, has member and component cannot appear in a profile because they're zeroed out. Interpretation will have a lower bound of 0, upper bound of 1, and subject will be required and appear only once. And of course, the Sushi compiler will enforce the rules that cardinalities must be equal or narrower than the cardinality of the parent. So all those rules, a lot of syntactic rules, will be enforced when you run the compiler. Then a very powerful type of rule is the choice restriction rule, which uses the only keyword. And here what you're doing is you're restricting down the data type of a element. So sometimes you'll see the X syntax, and for example, value X gives you a set of choices for that value. You can say value X only codable concept, which may cut out things like quantity and string or date time. And you can also make choices. So you can say effective X, which comes from a condition, only date time or period. So now you're restricting a choice of 10 things down to a choice of 2 things. And you can also do this for references. You can say based on is only a reference to a service request or a medication request. And we've used this vertical bar up to now. In the ballot, we got some comments to make that consistent with the or. So just be forewarned that this vertical bar may in the future change to the word or. Another really neat thing that you can do is you can restrict things to a profile. So for example, subject, it could be a patient, often is a patient. You can restrict it to a cancer patient, which might be a profile on patients. So that's a legal restriction because cancer patient is narrower than patient. Assignment rules are very common. The equal signs are used to set values of strings and quantities and dates and times. You'll see that all over. For example, you can set a code to a loink. Don't forget the hash sign is the way that we represent a code. So this is loink code 88040-1. You can say active is true, that's a Boolean, or onset date time, that's a date. And here's a quantity. One fine point is that in an instance when you do this assignment, this is just assigning a value, but in a profile, the equal sign actually says that the any instance of that profile must match the pattern of that value. So we can go into that more, but that's kind of a fine point. The other frequently used rule is the value set binding rule, which is saying that the value has to come from a value set. So we use the word from. So here's an example where the value codable concept has to be from this condition status trend value set. And we use the strengths of required, extensible, preferred, and example, just like FHIR. Here we're making it required. The last one I'll introduce is the extension rule, which uses contains. Just as a little backup, every resource has an extension array, and every element in every resource has an extension array. And the contains grammar populates those arrays with extensions. So what we'll say is something like extension contains evidence type with a local name of little e evidence type. And this this capitalized evidence type refers to a standalone extension which is defined elsewhere. So this is a little bit advanced, but then we can take that evidence type by its local name and let's say bind it to a value set. That's just about it for rules. I want to quickly mention that there's also rules that you can use for defining value sets. So as I mentioned, there's 8 or 9 different types of things you can do. A very common thing is to define a value set. Here we're defining a value set based on SCT codes. Well, what's SCT? That's something we define in an alias for SNOMED. So this value set, the condition status trend value set, has these 5 values that come from SNOMED. A very, very useful thing is to define instances. Instances are very, very useful. You'll need to define them associated with a implementation guide. In fact, the IG publisher will complain if you don't have example instances of every profile and extension in your IG. So to define an instance, we use a keyword instance of. This is kind of like parents for a profile, but this says which profile you're making an instance of. And then the kinds of rules that you define will usually be fixed value rules, because those are, in an instance, you're fixing values. So fish in practice. So the first thing that so now we've seen that you can write a profile in FHIR using some very simple statements. They're declarative statements which just say what you want to have happen. So how do you make that actually happen? Well, the first thing you want to do is actually create an environment for editing FHIR files. So then you can, create your own FHIR. Really, any text editor can be used. We suggest using Visual Studio Code because that's we've got a neat plugin for that, which gives you colorization of code. So that's part of installing and running. I won't go further in the interest of time. But if you load up Visual Studio Code, click in the left, you'll see this odd looking icon. And if you save out your file with a .fsh extension, it'll actually suggest this. And then you'll get colorization with the keywords in blue and strings in amber colored and that sort of thing. So that's real fun. And then what happens to your FHIR files when you process them with Sushi? Well, you start off, let me talk you through from the beginning to the end in the next 2 minutes, and then I'll hand it over to Chris. You'll create your FHIR files in a directory, which, as I mentioned, we call a FHIR tank. That's just your project. You'll create some configuration information in a file called config.yaml. And together, these 3 things can those are enough to run the Sushi compiler. So you'll actually open up a command window. After you install Sushi, you'll run the compiler, which slices and dices your fish into a set of profiles, value sets, extensions, examples, all the things that we've talked about thus far. Then you will create other accoutrements that you need to create an IG. You can actually stop there, or you can go further. You can create pages, menus, images, all these things that you need to create an IG. Then you can run the FHIR IG publisher, which runs the IG generation process to give you an implementation guide. And you can think of the implementation guide as the menu for all the things in your IG. It's a menu for which profiles you've created. It describes them. It lays them out for your users. The other thing that has recently been added is the ability for the FHIR IG publisher to actually run Sushi for you. So if the IG publisher discovers a directory called fish, FSH, it'll run the Sushi compiler, and you can just do all these steps in one fell swoop. So we're at the top of the hour. I'm going to turn it over to Chris, who's going to be running the Let's Build session. So Chris, I'm going to stop sharing my screen and you can share yours.
Sounds good. All right. So welcome everybody. I'll be running the Let's Build session, which will be happening on Wednesday from 2 until 2:40 p.m. So for those of you who are interested in participating, I recommend you go check out this page in Whova if you find the FHIR Shorthand on Wednesday. And at the bottom, we have a download button where you can actually download the exercise. Once you download this, you'll get a PDF, and that PDF describes what we're going to be working through. So essentially what we're going to be doing is taking the US core patient profile, and we will be recreating that profile and its associated value sets and extensions using FHIR Shorthand and building those into a simple implementation guide. Now, I apologize for the US-centric, US core profile, but you know, it does say at the top of the page, HL7 FHIR DevDays US. So I guess if you're not from the United States, just consider yourself lucky that you didn't have to actually fly a plane over here to participate. So if you look at this PDF, you'll see that we have a number of requirements. These are the things that you're going to need in order to complete this exercise. A text editor, as Mark noted, Visual Studio Code is really helpful just to actually show you the difference. This is what you would be looking at with Visual Studio Code. Still a lot of text, a lot to process, but this is what it looks like in a normal text editor. So I'd much rather look at the thing on the left-hand side, so we do highly suggest Visual Studio Code. You're also going to install something called Node.js, which is a JavaScript runtime that's needed to run Sushi. As Mark mentioned, Sushi is our FHIR Shorthand compiler. It's actually an acronym, of course, for Sushi unshortens shorthand inputs. That is a recursive acronym, a self-referential acronym, Sushi unshortens shorthand inputs. And then to run the IG publisher, which is created by HL7, you need Java. So you need OpenJDK 8 or a licensed version of the Oracle JDK and Ruby and Jekyll. And we've linked how to install all those things here. There are also some other resources that will be helpful, such as the FHIR Shorthand May ballot specification or the updated one, as Mark linked to in his other thing, US core patient profile, and a Let's Build starter project. At the bottom of the page, we have a link to the detailed instructions, which will bring you to a page like this. And from here, we see some of this information repeated, but we also have the steps. Now, this is 12 steps in the exercise, but we've designed it to be progressively more complicated We do recommend that everybody do steps 1 through 7 because we feel that that's what's most helpful to get a feel for FHIR Shorthand. But then once you get past 7, only the overachievers need to do steps 8, 9, 10, 11, and 12. But if that's you, then please, by all means, do it. You'll see that some of these steps are really easy. Installing the required software, reviewing the basics of FHIR Shorthand. Actually, if you're in this tutorial now, you can probably skip this step. And then the Let's Build Starter project. So when you download the FHIR Let's Build Starter project, you'll get a very simple directory structure. We didn't want you to have to start from scratch, so we did create a little something for you, but the emphasis on little. There isn't very much here, but there's a few scripts, a configuration, and then there is a patient FHIR file that's actually empty. You get to fill that out. So through this exercise, as I said before, you will be creating the US Core patient profile. In my last minute, I'll just show that to you real quick. This is the US Core patient profile. I apologize for the fast scrolling, but during this exercise, if you go through step 7, then you'll basically be creating a page that looks like this, has the must support flags, and has the cardinality constraints, and that's it. If you choose to keep on going, then you will learn how to do things like binding value sets, creating the value sets that you're binding, creating extensions, creating the value sets that go with the extensions, things like that. So that's basically what you'll be doing. We try to guide you along the way. So you'll see here, we have links to the relevant parts of the specification so that when you're doing something like adding cardinality constraints and must support flags, we provide the links directly to the FHIR Shorthand specification that shows you what you're going to need to do, but we don't tell you how to do it here. You get to find that on your own. You know, the old saying like teaching a person to fish rather than giving them the fish. I guess that's what we're doing. So anyway, that's it. And we hope that you'll participate and have lots of fun. And then when we get together on the Let's Build session, we'll actually go through the solution.
Hey,
Questions?
Chris and Mark, yeah, there's a couple questions. Did you want me to read them to you, or did you want to answer them?
Yeah.
Yeah, so one question around a project you presented previously called Simple, CIMPL, and is there a relationship with that project in FHIR, or is that a totally separate thing?
That's a great question. So whoever asked that question has a great memory. So actually we've been, MITRE, Chris and I, we've been playing around with languages to define profiles for quite some time. And you can think of FHIR Shorthand as our second or third go round, which partly accounts for how fast and how, if I have to say so, how well we've done it this time around. And Simple was a previous iteration, which had a few more complexities to it, I guess. So you can think about Shorthand as a replacement for Simple.
A simpler version of Simple.
Even simpler and well.
Nice. Yeah, I'm starting to use FHIR Shorthand quite a bit. There's another question here about kind of, I guess, an init script or some way to kind of get started. We saw your link to the kind of setup for the Let's Build It, but maybe just generally, what if people have ideas for features, what would be the best way to kind of get those in front of you all?
Sure.
Great. So, go ahead.
Okay. Yeah, so the init script is actually something we've thought about and we want to do. So the idea that you could run Sushi and say init, and it'll create a directory structure that is a good starting point, much like the download, the FHIR Shorthand starter kit that you can download as part of this this exercise. But we haven't done it yet because actually there was a lot up in the air regarding configuration and what a project structure should look like. Now that that's settling down, I think we'll look at that again. For people who do have suggestions for features, there's two ways that they can get in contact with us. One is on the shorthand channel on Zulip, and we're always glad to talk to you there. Another one is to just formally submit that request or that idea through our GitHub repository for Sushi. So particularly if it's a feature for Sushi and not for FHIR Shorthand, the spec itself, going through the GitHub repository for Sushi is a great way to go.
And I had a kind of a question. Can you speak a little bit to the relationship to the IG publisher and where you see Sushi going forward?
Sure. I guess I'll take this. I'll take this one too. So this is something we've been thinking about, and there's this kind of dueling sort of notion of Sushi and FHIR Shorthand as something just to create resources like profiles, extensions, value sets. And then there's also this notion of having to build an implementation guide. Got my 1-minute warning there. And there's lots of complexities in building an implementation guide that are beyond just creating the resources themselves. And so what Sushi does is we do try to make a lot of those easier. Some people really like that. They think it's great that we're trying to create some more user-friendly approaches towards that. Other people want Sushi to focus on the FHIR stuff. And so we're trying to navigate that and figure out how can we do this, and how can maybe we can take some of those things that we've learned through Sushi that are really helpful and actually make them a part of the IG publisher, so that more and more we're seeing those features land in the publisher proper so everybody can benefit, and then Sushi focusing more on just the definition. But it's a journey to get there.
I think one last quick question. Mark, I like your t-shirt. Where can that be purchased?
Well, only the founders and the people at the very first Connectathon have these t-shirts, but hopefully at future events, when we can actually attend together, we'll bring some more.
Okay, I think we're out of time. Hosts?
Thank you so much, Mark and Chris, for that excellent presentation. And thanks, Brian, for moderating. And thanks, everyone, for joining this session. Till we meet again, probably we'll see you in the next session. Talk to you soon. So bye, everyone. This is Sadhana Alangar, HL7's Director of Education, signing off.
Thank you.
Bye.
Bye.
Bye, Mark and Chris. Bye, Brian.